Kumar sir,
Yes, Swami.
we can start, sir.
Okay, sir.
Okay.
Good morning to one and all present here.
Morning.
Good morning, sir. Lakshmanan, sir. Good morning.
Good morning. Good morning.
On behalf of Department of Mechanical Engineering, I am very much glad to have this opportunity to welcome you all for this wonderful webinar on role of mechanical engineers in society. That too, our chief guest, R. Lakshmanan, senior consultant, TAPAMS, on this morning. First of all, I welcome Honorable Chairman, Honorable Co-Chairman, Director, Dean ENT, Vice Principal Academics, and Vice Principal Admin, and all the HODs of the department. And I extend my warm welcome to our Honorable Speaker, Mr. R. Lakshmanan, Senior Consultant, TAPAMS, for his wonderful guest lecture. And I extend my warm welcome to all the faculty members and participants of this event. Last but not least, I extend my warm welcome to all the students of this event. Thank you. Have a great day. Now I request Dr. Swaminathan to introduce about the speaker. Swaminathan.
Yes, sir. Good morning. Good morning, one and all present here. I feel happy to introduce our today event chief guest, Mr. R. Lakshmanan, sir. So he has completed his graduate in mechanical engineering from NIT Trichy and his master degree in industrial engineering and system from NJIT USA. He has more than 35 years experience in manufacturing industry and process and IT consultancy. He has worked various role in industrial engineering, production engineering, production, new product development, materials planning, procurement and quality, project management and project governance in industry and consultancy. He undergone training in lean manufacturing concept, business process, re-engineering methodology at Lucas Engineering and System in UK. He has managed more than more than 10 projects in business process and re-engineering projects for Lucas Engineering and Systems UK and CAC Manufacturing UK. He headed quality assurance at printing and packaging unit. He ensured product and process quality, getting a site certified for ISO and BRC IOP and training in SP and 7QC tools. So coordinating customer and system audit. One more project is managed implement on blow film and CCP plan for printing and packaging industry. He undergone leading auditor training in international quality rating system and its linkages to ISO 9000. So apart from this 35 years, 4 years experience in IT industry as SME manufacturing and senior project managers. Over 3 years of experience in JD Edwards, ERP project management and project governance. Over 1 year experience in project managing and SAP implementation in printing industry. And apart from this, he is a vibrant team player with a belief in taking positive approach towards the issue resolutions. I welcome you, sir. So now I hand over the session to Mr. Lakshmanan, sir.
Thank you. Thank you, sir. Thank you, Swaminathan, sir.
Thank you.
And first of all, good morning to all of you. And I would like to keep this session as interesting as possible. And more importantly, I would like to dwell upon the opportunities available for the mechanical engineers. I think that would be a great service of this particular session. See, if you ask me, I can finish this session in one sentence. We cannot imagine even one day without the contribution of mechanical engineers, and that is the truth. Okay, we can really finish this entire session by telling this one sentence, but in order to make it more interesting, I have added a few more topics to this session, which I will discuss with you. Can you go to the next slide, sir? Agenda slide. So let us first start with introduction, and in that we will talk about first of all what is engineering, and from engineering then we will come down to mechanical engineering, and there are also other overlapping disciplines in mechanical engineering that also we need to understand. In life, we are not alone. So there are also other disciplines of mechanical engineering that also we will discuss. Then let us briefly look at the history of mechanical engineering in the world and especially in India. Then we will come to the main topic of in the role of mechanical engineering in society. And as I told you earlier, I would like to dwell more upon the job opportunities that are available for the mechanical engineer. And with that, we will conclude this session. In case if you have any doubts during the course of this talk, you can interrupt, or probably you can ask these questions at the end of this session. Is that okay? Okay, we'll go down. Go to the next slide, sir. Sir, go to the next slide. Hello?
Yes, sir. We are in second slide.
No, next slide. After agenda. Okay. No, yeah.
Yes.
See, first of all, this engineering is basically the use of science and math to design or make things. For example, engineering is actually nothing but an application of the basic sciences. For example, engineers usually design and build things, whereas some scientists only explain what is available in nature. Probably I will explain this in more detail in the next slide. And some engineers are also using their skills to solve technical problems. So let us first look at the difference between a scientist and an engineer. Go to the next slide, sir. See, scientists study the world as it is. They just explain what is happening in the nature. For example, Newton, he observes the falling apple, and then he talks about Newton's first law of motion, second law of motion, and maybe looking at an action and a reaction, he created a third law of motion. They are only expressing what is happening in the nature, whereas engineers create the world that has never been. For example, the nature did not create a car. The nature did not create an aeroplane. The nature did not create a refrigerator. The nature did not create a cooking pressure cooker. All these things are man-made, and anything man-made, definitely there is an say, for example, scientists try to understand and explain the nature, whereas engineers try to make things that do not exist in nature. For example, if you look around you, there are many objects. I'm actually sitting in my office, and when I look around, I see laptop computers, I see AC. When I look out of the window, I see car. So many objects are there. All of either they are static or they are moving, and all these objects are made because of engineers effect. Okay, let me first take you through a few examples. Newton's third law of motion says every action has got an opposite reaction. Okay, so he has just observed the nature and he has explained this. Now, the application of this principle is your rocket propulsion. And the rocket goes up, it flies because of this application of Newton's third law of motion. Similarly, we say Michael Faraday's principle, we find that these three are related. That is mechanical energy, electrical energy, and magnetism. These three are related, interrelated. And suppose if I give two, the third one is produced. This principle is used in the electricity generation. In electricity generation, what do we do? The turbine rotates because of some mechanical action. Maybe in hydroelectric power due to the waterfall, or maybe in nuclear engineering due to the steam pushing the turbine. So mechanical energy is created, and the turbine rotates in a static magnetic field, electricity is produced. So the principle of electric generation is basically applicable on the Faraday's principle. Similarly, when you take an aircraft, okay, it is basically created based on the Bernoulli's principle. The wing, when you take the wing of the aeroplane, the upper surface is smooth and the lower surface of the wing is flat. So when the air flows, basically you will study this in fluid dynamics. When the air flows very smoothly on the upper surface, whereas in the bottom surface it flows slowly. So there is a pressure difference. So there is a higher pressure at the bottom and lower pressure at the top. So because of that, the aeroplane is lifted. So this is basically Bernoulli's principle. So like that, in nature, we can find many principles which are converted into useful appliances for both society as well as at home. For example, we also know when the temperature increases, the boiling point also increases up to the critical point. The same principle is used in our pressure cooker. So that, when we cook anything under pressure, then the time of cooking comes down because the temperature rises. So these are all some of the principles, just some examples I am telling, where the basic scientific principle is converted to an application by engineers. So now I hope you will know the difference between a scientist and an engineer. And as you can see in all these examples, some mathematics or scientific principle is used. In fact, for many of them, there are mathematical equations available. Any doubt on this before we move on to the next slide? Okay, go to the next slide. So now let us talk about what is mechanical engineering. The first thing what I have done is I have taken an example from Wikipedia. Basically, it says mechanical engineering is an engineering branch that combines physics and mathematics with the principles of material science to design, analyze, manufacture, and maintain mechanical systems. It is one of the oldest engineering branches. Obviously, if you track India's progress, if you ask your great-great-great-grandfathers, they will say many of them would have been civil engineers, because civil engineers were required those days for building the society. Then after that, during Nehru's period, came the mechanical engineers. Then later on, electrical engineering becomes important. Now today is the and after that, electronics and communication became important. Now probably today is the day of computer science. So like that, if you really look at engineering, also progressed and also bifurcated from the parent engineering into specialized disciplines, and that is how the country and the entire world has grown. Now there is one more interesting definition. Mechanical engineering create and develop mechanical systems for all humankind concerned, applying the principle of force, energy, and motion. This is what I was just explaining to you in the previous slide. I gave the example of the rocket propulsion, where this Newton's third law of motion is applied. So basically, mechanical engineering is concerned about creating systems, applying the scientific principles, and those systems are helping the humankind. They make the life easier. That is the real contribution of the mechanical engineer to the society. Go down. Go to the next slide, sir. Now, as you can see, mechanical engineering doesn't exist in isolation. Actually, it has got an overlap with civil, where suppose if you take you might have studied Lamy's theorem, the structural analysis, etc., etc. When we create, bridges, when we create, physical structures, even buildings, all of them is an integration of mechanical and civil engineering. Similarly, when you make even cement for civil engineering, mechanical engineering is required, because without mechanical engineering, how will you make a rotary kiln, etc. Same way, mechanical engineering also overlaps with electrical and electronics engineering and EEE also. Just now I gave you the example of electricity generation. So obviously there is an overlap between mechanical and electrical engineering. And electronics and communication, basically it is revolving around walls and so many things. Nowadays, we can take many applications of electronics and communication engineering like IoT, etc. All of them, they definitely has an overlap with mechanical. Similarly, chemical engineering and computer science. Okay. The only difference in computer science is, in all the rest of the engineering, for you to do, higher studies or engineering courses, you have to join an engineering college. Whereas in computer science, even people with, mathematics background or BCom background, anybody can do, because computer science is basically an application engineering, whereas the rest of them are all core disciplines. Okay. And computer cannot work on isolation. Definitely, it has to depend on the core only. But in India, the demand and the salary for computer science engineering is more, because in terms of computer engineering, the market is abroad. the labor is in India. So there is a difference of, there is a huge difference of profit. So the computer companies, the software companies are able to pay more money. So because of that, the attraction is more. But if you really look at computer engineering on its own cannot do anything unless otherwise something is created. Computer engineering cannot support them. So please understand, there is a value for joining the core discipline, and the demand for core discipline will never come down in this society. Okay, let us go to the next slide. See, there are many core areas of mechanical engineering. In fact, I am trying to explain that briefly. Some of you who have done this course definitely will understand why these subjects have been included under mechanical engineering. For example, mechanical engineering includes mechanics, dynamics, thermodynamics, material science, structural analysis, and electricity. And of late, we are also including computer-aided design and computer-aided manufacturing. In fact, in '83, when I was pursuing my master's in US, and that was the time when these subjects, computer-aided design and computer-aided manufacturing, were actually taking shape. Then product lifecycle management is also another area. And these are used for analyzing the manufacturing plant, industrial equipment, machinery, heating and cooling, even refrigeration and air conditioning is also a subject under mechanical engineering. So heating and cooling system, transport, like that, there are many applications. So let us take one by one. It is better to understand the spectrum of mechanical engineering before we go into the contribution to the society. Can we go to the next slide, sir? So next slide. Okay. See, the first branch of mechanical engineering is under thermal. In that, I am sure in the current curriculum also, there will be a subject on thermodynamics. Okay. The science of thermodynamics deals with the amount of heat transfer a system undergoes, a process from one equilibrium state to another. We all know that any matter exists in three states. One is the solid state, then liquid state, and gaseous state. Especially in terms of, in this case, we are talking about liquid, and we know that we have got a conduction, convection, and radiation. So these are the fundamental principles which are used in thermal engineering, and this is what is being actually used in our engine design. Okay, so heat transfer, thermodynamics is one of the important subjects. Sir, go down. I used to explain this conduction, convection, and radiation in a very interesting manner. Suppose assume some 10 students are sitting together, and if I give let us say a tennis ball to the first student, if he passes it to the second student, then third student, fourth student, if it reaches the 10th student, that is conduction. The radiation is the 10th student coming and then taking the ball from the first student. And that is a convection. Radiation is the first student throws the ball to the last student. So this is a rough example of conduction, convection, and radiation. In all these cases, the ball, which is the heat, gets transferred from one atom to the other atom. Now, in terms of the other subjects under thermal, energy conservation is another important topic. For example, this concerns with conversion of these fossil and nuclear fuels, and also of late this solar power. So why I am telling all these things is later on when I talk about job opportunities, you can relate how important these subjects are. Okay. Similarly, fluid mechanics. I also gave you an example of this aircraft industry, and this aircraft lifting is purely by fluid mechanics. And again, the fluid mechanics, we talk about properties of fluid such as velocity, pressure, density, temperatures, etc. In fact, later on when I discuss, you will be amazed to see how Indians, the historical Indians, we also knew about this fluid mechanics. Later on, we will see this. Okay, go down. In terms the other major area under mechanical engineering is design. In that, first one is the static. Static is the branch which is concerned with the analysis of load, basically torque or momentum, and in a static equilibrium. So there is no motion involved, and definitely there is a subject. In fact, this is one of the questions taken from the question paper. There they will give you some two forces or load, and then they will ask you to calculate the third force. Okay, these kind of analysis are required. This trust analysis, these are required, as I told you, in the design of bridge, in the design of house, etc. So this is one of the important subjects, statistics. Similarly, theory of machines. In fact, from my days, I think the Bevan, Thomas Bevan's book is very famous. In fact, we used to have a professor called C.R. Kandaswamy in REC Trichy those days. And, I still can't forget the way in which he taught us, these Coriolis component and, the various, the elements that are involved in the automobile design. So theory of machines is a branch of engineering which it concerns with the relative motions between various parts. Okay, so this is also another important subject, and based on this only gears, the various types of gears, everything evolved. In those days, we used to have a PhD design data book. With that, we used to design things. Then comes the kinematics. So as against the statistics, kinematics is basically dealing with the motion and basically conversion of the relative motion between various parts. In that, fundamentally, there are 4 kinematic equations. Okay, as you can see, there is always a science and the maths involved. Okay, so these are all some of the subjects under design. Okay, go down, sir. And dynamics is another one, and gyroscope, you might have learned about gyroscope, and definitely dynamics plays a very important in space technology. Then material science is also part of mechanical engineering only. Later on, of course, the specialized branch of material science became metallurgy, but definitely material science is part of mechanical engineering, in which we talk about characterization, structure, property, performance, and processing of the material. Okay, so we should know exactly what kind of material to use and then choose. In fact, if you are very much interested, you can go for companies like a casting and forging companies, where basically they melt the base metal, then convert that into a forging or a casting. So a combination of mechanical engineering and material science will be helpful in those industries. Go down. Then vibrations. Vibrations is again another important subject, because in the real world, definitely vibrations are there. Obviously, sometimes they are helpful and sometimes they will deteriorate the conditions of the machine. So unless otherwise we clearly understand the mechanics behind these vibrations, we may not be able to function as a mechanical engineering. Sometimes these things will be useful when you go as a maintenance engineer in an organization. Then the last one is the CAD, computer aided design, and that is a bridge between the computer and the mechanical engineering. Today we can foresee the design in the computer. We can even do a simulation by running the design in the computer to see the effect, and then accordingly we can make some changes. In fact, the off late one more branch which has come is the manufacturability, design for manufacturability. In fact, when I was there was a course called Boothroyd Index. Okay, we used to take a design, apply this Boothroyd Index, find out, and then every time when we make the design change, we would like to, the objective is to improve the Boothroyd Index. So by that way, what will happen is slowly the design will become susceptible or easy for manufacturing. So these are some of the concepts that are related to design in mechanical engineering. Sir, go down. The most important area is production. In fact, many of you as mechanical engineer will enter into this field. So under production, manufacturing is the first area. So what will happen is many of you may join a manufacturing industry. When I say manufacturing need not have to be only automobile. Manufacturing can be anything. It can be wood, it can be paper, it can be plastic, it can be even steel, it can be cement. Take any material, base material, getting converted into a product, then there the manufacturing gets involved. And when manufacturing is there, definitely there is a scope for mechanical engineer. Okay, what mechanical engineer can do, I will probably explain you when I come to the slide on job opportunities. But right now, please understand why I am taking a lot of time and energy to explain each of these disciplines, depending on your interest. Suppose tomorrow you want to go into, let us say, production area, then better concentrate on manufacturing and metallurgy. If you want to go into, an application of computer, then concentrate on computer aided design. If you are a machine oriented guy, a design oriented guy, then choose any one of them, either a static, a kinematic, or a thermodynamics. Accordingly, you can go into General Electric on companies which maybe within India. If I can immediately recall Simpson, which is making automobile engines. So you can join those companies. So depending on your interest, you should concentrate, because even if you are a champion, you cannot run in north, south, east, west at the same time. You have to choose what you want to do in your life depending on your interest, and then choose the subject and then concentrate. That is the reason I am spending a little bit of time in what are the branches, sub-branches under mechanical engineering. And the next one is the metallurgy. Metallurgy is also, actually nowadays, metallurgy is offered as a separate branch itself. But if you really look at, there is a strong overlap between metallurgy and mechanical engineering. And basically, there is a physical metallurgy, extractive metallurgy, and mineral processing. Physical metallurgy deals with problem solving. For example, what are the alloys that are needed for different types of manufacturing and construction? Similarly, extractive metallurgy involves extracting the metal from the ore. Obviously, you will join companies where a ore is converted into a metal, like for example, Tata Steel. Okay, so they convert the iron ore into, let us say, an iron ingot or iron bar. Then after the iron bar is taken, and then it is either rolled or made into a flat or made into ice section. So like that, there are many chain of industries available. So these things again definitely require a mechanical engineer. Sir, go down, sir. Go to the next slide. And just to continue the production, the automotive engineering is a very popular field, and especially South, especially Bangalore, Chennai, and Hyderabad put together, we are almost catering for 80 to 90% of automobile fields. You can name many companies starting from Volvo, Mercedes-Benz, Ashok Leyland, all the TVS companies of different parts. Lucas TVS itself, if you take, we make alternator, starter motor, distributor, headlamp, horn, flasher. Then you take the entire Simpson group, we make pistons, we make engines, we also make different parts. And apart from that, for transportation, if you take TA cycles, we make cycles. So when you say automobile engineering, there are many, and the Rane group, we make engine walls, we make brake linings. In TVS, again, we have Sundaram Apex, and wheels, we have Wheels India. So I'm giving you all these companies definitely require mechanical engineer depending on the vacancies, and all these things put together make different components of the automobile engineering. Okay, and we are also having manufacturers who make automobiles here. For example, we have Nissan, we have Ford was there, of course, now it is closed. Then we have Hindustan Motors, okay, in Tiruvallur, and now the French company PSA has also come into India, I mean in Chennai, and we have Ashok Leyland. So, and if you go to Hyderabad, we have Kia. If you go to Tamil Nadu, Bangalore border, we have Toyota, we have Volvo. So we have both Indian and companies which are, and not to forget Hyundai in Chennai. So there are many Korean, Japanese, Swiss, Swedish, American companies available. It all depends on your interest, and you have to be really good in your skill. Definitely doors will open for you, no doubt about it. Okay, and people are ready to pay the right amount for the right amount of people. Okay, so automobile engineering is another big field. Similarly, engineering economics is also becoming another field. Basically, in economics, what are we trying to do? We are now taking a particular proposal, and we estimate what is the investment for that. So we do a cost benefit analysis, and we choose the correct investment, and then we do a marketing. So these kind of disciplines are also emerging in mechanical engineering. I don't know whether this is being taught as a course in the curriculum, but this is also emerging field. So just to go to the next slide, sir. And we have two more areas. One is the automation control. I'm sure some of you might have, studied control systems, basically feed forward and feedback systems. And this is something which is overlapping with our, electronics and communication system. So whenever we talk about artificial intelligence and all those things, all of them are, to my understanding, they are all based on feed forward or feedback systems only. In fact, I still remember my professor KLP Mishra, who used to teach us in 1983. Very interesting in those days. In those days itself, REC had these courses. Okay. Then industrial automation and robotics is absolutely a modern, area. And I don't know whether SRM has a course on the industrial automation and robotics. And definitely in future, artificial intelligence and robotics will pick up. And don't think robotics will be a hindrance to human. Actually, robotics should be applied in areas where humans cannot work. For example, if you go to Hyundai or any other company, you may see robotics in the spot welding. And when they weld the body of the car, they will be using the robotics. It is not that, a robot is cheaper than a human labor. The reason they are using robotics is repeatability. The robot will precisely, weld in the same spot. So what will happen? Suppose if the welding spot is slightly shifted here and there, then the load structure of the car will change. So they want a repeatability. So definitely robotics is the best choice. Similarly, I am actually currently doing a project for Tata Motors, Tata Marco Polo. In fact, Monday I am leaving for the factory. So there also, when we make the bus body, we are using robotics only. The same way, robotics are also used in places where humans cannot go. For example, in mines or in nuclear kind of situations, definitely robots will be helpful. So definitely robotics is a promising field. Similarly, industrial automation is also a promising field. And if some of you are interested, then you please pursue this line. And of course, this is again related with mechanical engineering, automatic control, and previous design and other things, whatever I have told. So no subject is in isolation. It is always overlapping with the other area. So you must really concentrate and then study. Definitely the doors will open for you. Okay. Please go to the next slide, sir. Having said all these things, let us now go back to the history of mechanical engineering. See, if you take the earlier days, there were 6 simple machines. For example, the first one is the lever. Okay. I don't know who said this. I think Archimedes or somebody. He said, give me a space, give me a place for me to stand in space and a lever, I will lift the world. That is what his, the sentence is all about. What it means is, by applying a lever principle, by applying a small force in one end, we can actually carry or lift a huge load in the other end. That is the application of the. So obviously, we need a lever and a fulcrum, and depending on where we place the fulcrum, we actually manipulate this. This is a simple mechanism, and one of the applications of the simple mechanism is the scale. Okay, in the scale, obviously, the length of the 2 sides have to be equal. Then accordingly, we will know exactly whether the weight is correct or not. Okay. The second principle is the inclined plane. Okay, only with the inclined plane, we are able to move objects to a height. The best example in Tamil Nadu I can give is Tanjore Temple, where at the top of the, that tower, that Gopuram, what we call Gopuram in Tamil, in the top of the tower, there is a monolith. There is a huge rock. Okay, how did they move this rock? So one of the principles people talk is Rajaraja Chola built an inclined plane, and then he made the elephants to drag the, the stone. He kept it up. After that, he removed the inclined plane. This is one of the theories told. So inclined plane is also a simple mechanism. See, basically, what we are trying to do is we are trying to take a mechanical advantage. Okay, by using these simple tools, we are trying to reduce the human effort. Imagine if your house has got some 4 or 5 steps, let us say, and imagine that you are moving your motorcycle without an inclined plane. You know how difficult it is. Simple things. Okay, so inclined plane is another important invention. The third one is the wedge. Wedge is like your chisel. So by using this wedge, what you do, either you separate 2 objects or you remove some objects. Without chisel, people would not have created sculptures. People cannot do a carpentry. Today the single point cutting tool is nothing but a wedge principle only. Okay. Another important company, when I talk about tools, which comes to my mind is Vidya in Bangalore, and also there is an equivalent company in Simpson Group also. Again, if you are interested in cutting tools, that is a different and similarly Carborundum Universal. Okay, so these are all some of the companies which are involved in this kind of technology. The third one is the pulley, and we know pretty well pulley is another modified form of lever and lever. where it is also used for lifting loads. Okay, the best application of pulley is, in olden days we never had a motor, so we had to draw water from well, and we use only pulley. And again, in pulley there are many mechanisms: single pulley, double pulley, all those things you might have studied. And the fifth one is the wheel and axle. So wheel and axle is also another important thing by which you are able to move lot of material. Okay, so wheel and axle is another, wheel borrow, what is called. The last one is the screw. So in screw, what are we doing? By giving a rotary movement, we are trying to move things in a laterally. Okay, so this is also another application. So if you really look at, these are the 6 simple machines which were found in olden days in different countries. In the subsequent slide, I will explain you who did what. And in today, believe me, in today machine also, any machinery, if you take any machinery construction, if you take and then try to, break it up, ultimately you will end up with one of these 6 mechanisms, because these are fundamentals. Like the car body can change, especially in auto and diesel motors. I am not talking electric motors. In auto or diesel, definitely the basic principle of diesel cycle and auto cycle has not changed. We have changed only the body of the design, the color of the design, hatchback, this and that. But definitely the fundamental mechanisms remain the same. So it's the same way in modern times, when you take any machine and break it down to the lowest pieces, ultimately you will find these 6 mechanisms getting applied. Okay. With this, let us now go to the next slide, sir. So the wedge and inclined plane were actually known in prehistoric times, because obviously the man made tools for killing animals. The moment, I don't know who did the first tool, the moment the fellow did the first tool, then mechanical engineering was born. Okay, obviously is a mechanical engineering. Without that, how you would have killed, or how you would have removed plants from the earth. So the wedge and inclined plane was the prehistoric times. Then the wheel and barrow was actually found in modern Iraq, which was in those days called Mesopotamia, which was in 5th millennium BC. Similarly, the lever mechanism first appeared 5,000 years ago, especially I think in the balance scale. To my mind, both Egypt as well as in China. Okay, Chinese are also very clever people. In fact, they really made it as a secret. They never shared with the other world, but otherwise they were also parallelly making so many inventions. So balance scale was also invented in ancient Egyptian technology. Then there is something called a shadow. Shadow is nothing but water lifting mechanisms. Like we use the bulls to go around a field, and then they will take water from the well and then pour it to the field. So that is a kind of the arrangement. Similarly, crane mechanisms, pulleys was also in Mesopotamia. Then in Kingdom of Kush, again they developed something called a Sakya. Sakya is something similar to shadow. And so many of them were actually related with removing water, because water is the fundamental thing that was required for humans. So to pull out water from a bottom, many of these mechanisms were found out. Go to the next slide, sir. And this a lot of information is available. Like for example, steam powered devices were actually found. In fact, I had visited a museum, James Watt Museum in Birmingham, and people found out that the steam when the steam expands, it does work. Okay, so by using that only, many of the steam engines were created. Again, that steam engine was used in power looms. The steam engine was also used in the moving the the railway track. So you remember in old days, steam engine, water, and the charcoal, everything used to be used for creating steam, and then steam engine, and later on steam engine was also used for creating electricity. And there is also an example of a water clock in China, and seismometer is basically for finding the vibrations, and differential gears. In fact, for chariot, they are also invented a differential gear. Yesterday I was watching a video on this Thiruvarur, the Rath, which is a very big one. Actually, applying this principle, they have made some differential gears for that to move the to rotate the to make the Rath turn in a smooth way. And medieval Chinese horologists incorporate escape mechanisms, and again clock tower, chain drive, and Muslim inventors have also made remarkable contributions. And there is a book called Book of Ingenious Devices in 12,206 itself. I don't know whether a copy is available. So all these things show that mechanical engineering has been in the history for a very, very long time. Okay. So I have talked about all the other countries. I mean, those olden mechanism, civilizations like Iraq, Persians, then about Chinese, then about Europeans, then about even South Americans. But now let us look at how it was in India. Go to the next slide. Okay, some more contributions are also there, leading to the modern American Society of Mechanical Engineers, American Society of Civil Engineers, etc. So let me not go through all these things. Go to the next slide. Okay, now coming to India, actually the biggest contribution for especially for mechanical engineering by Indians is the mathematics. So this is a quotation from Albert Einstein. He says, "We owe a lot to ancient Indians teaching us how to count, without which most modern scientific discoveries would have been impossible." Okay. So one of the thing is, you must know the difference between an invention and a discovery. Invention is finding the basic principle. Discovery is applying that principle and finding an equipment. Okay. I have pasted a small portion which is actually a numerical notations used in Vedic text. In fact, some days back, I actually came across a video posting where again, see, in India, what happens is whatever we do, we're all related to God, because we never differentiated between science and religion. So whatever we did was always contributed towards God. So this poem is on Krishna, and what the beauty of this poem is, when you actually go to the construct of the poem in such a way that it clearly explains the value of pi to the I think to the 10th digit. Okay, very interesting poem. I don't know, I forgot to save that the video. So like that, the people had the knowledge of numerical knowledge, Indian context. Similarly, I have also cut and paste another portion, which is a method of solving intermediate quadratic equations. And of course, I need not have to emphasize on the use of ceramic technology. And this is a recent one which is found in Kiradi, near my place. I am from Madurai. So on the way to Madurai to Ramanathapuram, there is a place called Kiradi. In that there was an excavation recently, and these are the objects which were found out. I mean, I'm talking about some 2,000 to 3,000 years back. So if people can create such a fine, porcelain kind of a ceramic, then, they must have known metallurgy, they must be knowing the thermodynamic, they must be knowing the expansion, contraction, when to take, polishing, painting. I mean, all these disciplines merge. Then only they can make objects like this. And and of course, all of them, some of them have hollows, some of them have holes. So a lot of interviewed application of engineering is required, without which these objects cannot be made. And similarly, there is also a similar finding in Dharmaburi. Okay, that is also another pasting I have given. Sir, go down. Then we need not have to, of course, the metals and coins. These were also made in India throughout, and in recent history also we know Tughlaq also introduced coins. And idols, I mean, they are beautiful. In fact, since I'm from Madurai, especially when you enter the main shrine, on both sides you have a huge life-size, idols. I used to stand there and wonder how, intricately they have really done. They're all made of bronze. The nose, the even the nails, and even the thread. And when the lady, if a lady is wearing a sari, even the foldings of the sari. I mean, if you make one mistake, finished, you have to make another piece altogether. So somebody has made a cavity in such a fine fashion, poured the metal, cooled, then finished. Otherwise, he has not left his name. Even today, when you are writing a simple letter, also we put our name and then say we want the entire world to know that we have done it. But some guy has done it, and he has not even left his name to say that I have created masterpiece. I mean, really masterpiece. I don't know how they made all these things. And of course, the forged, see, these are all cast. Then forging is also very, very important. And all these swords and other things were also made of forged metals for different purposes. So this is just an example to show that how engineering was applied in those days. And I also interestingly, when I did some research only for this particular lecture, I found many of the terminologies were also in existence in olden days. Go to the next slide, sir. For example, this was an example of a vimana. Vimana is basically a flight kind of a thing. This is explained in Rig Veda. Okay. See, as I said, people left it as it is. They never pursued into practical things. In fact, in my younger days, when I studied school, there was a subject called Science and Tamil Literature. Okay. This talks about example is in Ramayana, when Jadayu, when he runs, he sees the tire marks of Pushpaka Vimana up to some time, and after that the tire mark disappears. That shows clearly, the takeoff cannot take place without a momentum. Whether it is true or false, whoever has written, including Kamba Ramayanam, clearly explains this particular situation where takeoff has taken place. Okay, obviously they had the knowledge of this flight. Similarly, there is one more lesson which came was this poet. He looks at this this deity, which is basically a female deity, Amman, who is sitting on a unjal, a swing jula, and when the jula is swinging, he is comparing the time period of the jula with the ear ring. Ear ring is also hanging in the deity, and he is comparing the time of oscillations of these two. Obviously, in that he is trying to express the relationship between the length of the jula and the time of oscillation. Okay, that is another interesting poem. I still remember that. The third one is this poet is walking through a garden in the early morning. So there were dews appearing on the grass. In the grass top there were dews, and he says in the dew he can see the palmyra tree, which is at the far end of the palmyra tree, is appearing in the dew. Actually, this is nothing but a telescopic principle. So why I am saying is there are poems and evidences, written evidences in the form of poems in different literatures, and I am just talking because I am exposed to Tamil literature, so I am talking about that. I am 100% sure such a similar things will be appearing in all the literatures of our India. So obviously what happens is people had the knowledge of science and also the application of these principles into engineering. Okay, you look at on the right hand side, so many terminologies, dhyana, udayana, sudhana, all these things are different technical parameters, taking off, flying down, Today we express this in different English terms, but all those things were available. And of course, most of them are in Sanskrit because it is from Rig Veda. Go to the next slide, sir. Similarly, in material science, so many, gravity, fluidity, viscosity, elasticity, conjunction, disjunction, springing capacity, refraction. I mean, without which, as I was telling you the example of life-size, models which I found in Meenakshi temple, definitely it would not have been possible unless otherwise people know the difference and how to handle these various properties. Go down. And similarly, in weight scales, we have so many parameters, kunja and suvarna. I don't know what this means. Similarly, in volume scales, distance scales, time scales. So all these technical parameters were available for different fields. Only thing, by using them only, people have created various objects. So we must understand that we are not doing something totally new. All these things are available in nature, and in those days people have dedicated their life only for godly living. So they have used their skills for creating various objects for these purposes. Okay, go to the next slide, sir. So now I think at least we should do justice for the the topic. To put it in simple fashion, whatever I have told you, definitely that is also related to the topic. What do we do as a mechanical engineering? How do we contribute? First, we eliminate excessive usage of resources by optimizing and improving efficiency. Obviously, when something is being done, we always improve, and also we try to reduce the excessive usage of resources and improve efficiency. For example, take in olden days car and modern days car. In olden days cars, a lot of fuel used to be wasted in terms of friction energy, heat energy. Now, slowly we developed the bearings, we developed the various mechanisms, and then also reduced the weight of the parts in such a way that your efficiency improved. So your fuel efficiency improved. That means what? We are conserving the fuel. Now, with the modern advent of this electric cars, the weight of the car will drastically come down. Almost 50 to 60% of the parts will go away, because it's a direct, we have kept an electric motor which is directly transmitting. So there is no need for a big, transmission rod and all those things, and the entire engine blocks go. So what happens is still the efficiency is improved. So this is just an example to say that how we eliminate the excessive usage of resources by optimizing and then improving the efficiency. And that's, of course, I should have put this point as the first one, to build things that make the world a better living space. If you look around, as I said, when you are sitting in a home, when you look around, you find a refrigerator, you find a cooking, cooking gas table. Similarly, you find a microwave oven, you find a mixie. All these things make cooking easier, and it reduces the labor of the housewife, and today, of course, the labor of the husband also. So many of these appliances make life easy. So these are just an example. Imagine if you don't have a car or a wheel was not invented, then you would have had it. I mean, how will you go from one place to another place? And today we are, whatever happening in one place, we come to know quickly. We are able to, within one day, we are able to travel from this side, or probably 2 days, we are able to travel from Japan to, the other end of the Canada. So it is easy for us because we have found out, various inventions, and definitely mechanical engineers have contributed to this. The third one is reducing the human effort and making work easier. And this is just a cartoon I found very interesting. Some people are actually pulling, and one fellow is coming with the wheel, and he says, no, thanks, we are too busy. Actually, he does not know the mechanical outage of the wheel. Okay. So these are some of the examples. So to put it in simple sentence, especially all engineerings, they reduce human effort and make work easy. Especially mechanical engineering is a fundamental thing. As I told you, it concerns with the moving mechanisms. So our contribution to the society is we actually make things which make life easy. And once we make things, we also work on that to reduce the use of resources and improve the efficiency. Okay, go down, sir. So this slide, I will spend a little more time. I think more or less, I think we have reached the end of the session. See, first thing, as you see in the clockwise, I will take automobile industry is the biggest opportunity. See, the way I am looking at in my experience, 35 years of experience, there are three kinds of people. Okay. The first kind of people, they are more design oriented. They are more technical people. Okay. So these kind of people are, very suitable for production engineering, or they are very suitable for design, or they are very suitable for maintenance engineering, because they don't talk with people. They talk only with the machines. They are interested in technology. In fact, they are also in, they will also be suitable for research and development, design, research and development. So there are many, functions available in a company, and I can see these four functions. First, R&D, production, then what is called methods engineering, and maintenance engineering, and of course the fifth one is also the fourth one, maintenance engineering. These four areas are more suitable for people who have got a an ambition, or who have got an inclination for design. The second set of people, they are gregarious. What is gregarious in English? That means they love to travel, they love to meet people, they want to be in the company of people. If you put them in solitary confinement, they had it. Because definitely in your student community, you enjoy the company of certain people. They will always be cracking jokes. They'll be very easygoing. They will move very freely with people. So these kind of people, they are ideally suitable for purchase and sales. Okay. Because purchase is also not an office function, that also involves engineering. Similarly, sales also, there is a technical sales. You cannot simply, anybody cannot go and sell a car. You should need to at least know the appreciation knowledge of a car. Then only you can go and sell. Okay. So these people are ideally suited for purchasing and sales. The third set of people are system oriented. These guys are very, very systematic. Even in your, in student life, you can see these fellows, they will observe timings, they will attend classes, even, they will, in simple, they will dot all the I's and they will cross all the T's. These type of people, if they are in a non-engineering function, they are ideally suited for a chartered accountant, because any chartered accountant has to be very, very systematic and methodical. Otherwise, it is very difficult to excel in their profession. Whereas in engineering, I can clearly see quality as one of the important area for these kind of people, because in quality, you have to be very system oriented. You yourself are not system oriented, then how will you ensure the system of the company? So I, first of all, you first decide from your characteristics, are you a design or a technical oriented person, or are you a people oriented person, or are you a system oriented person? Accordingly, you can choose a function. There are about some 10 different functions available in the company. Okay. Purchasing, sales, manufacturing, engineering, maintenance, design, human resources, etc., etc. The second thing is, having chosen that, obviously, I told you various courses or sub branches that are available in engineering. Depending on the industry, you have to choose. For example, if you choose automobile engineering, there are many opportunities both here as well as abroad. Abroad also, there are many automotive industries. So you can go for that. Again, as I told you, one more classification is, you can be a technical guy, you can be purely a managerial guy, or you can be a techno managerial guy. If you want to be a techno managerial guy, I like that area, because I also want to keep one leg in technology, one leg in managerial. So I chose industrial engineering and systems. That is an ideal area where it is techno managerial. Okay. Industrial management. There are very good courses available in many of the institutes. So automotive industry, lot of scope. And as I told you, many industries are in South India. The second one, the second sector is power and energy industry. Okay. Again here, when I say power, don't think only ONGC or IOCL, etc. Even nowadays, there are private players who are into wind energy, ROs. There are many companies who are involved in wind energy. Okay, who are also involved in making the wind energy components, Suzlon. So such companies. So they are in Maramalanagar itself. There are a few companies available, and especially in Bangalore, there are many companies available. And steel industry, Jindal Steel, Tata Steel. I am only talking particularly about India, but abroad there are many industries. Steel industries are also available. Then cement. Cement is again a oligopoly. Oligopoly means a few people, players are only there. And in Tamil Nadu, we have, Rajapalayam, we have cement industry. Chettinad cement is there. Shankar cement is there. Okay. So many cement industries are there. And of course, in North, there are many, because the construction industry will never die. Okay. Man always has a habit of wanting to own his place. So definitely construction industry will never even die. So definitely cement industry is another big scope. Then metallurgical industry. Okay, as I told you, things cannot be made of stone. First, it has to be cast, or it has to be, molded. And the same thing is true of plastic also. In plastic also, there is injection molding. So all these things are related to metallurgy. Then consumer goods industry. Actually, I have left out plastic industry. That also should be added along with metallurgical. And consumer goods industries are many. For example, your TV, the fridge, microwave oven, and even your smartphones, all are falling under consumer goods industry. In this, there are many Korean companies like Samsung, LG, even Philips. So many companies are there. So this is also offering you another, again, all these plastic parts, everything cannot be made without mechanical engineering, even though it has got a lot of electronics and communication, and of course, computer science also. Without the physical parts, how will they make this product? So there is a scope for mechanical engineer. Then pharmaceutical. See, while I am doing this, I will stop at this moment and say something. When the disposable income of any individual or any country increases, disposable income means what? Some extra money I'm keeping in my pocket. When such a situation arises, three industries will always flourish. One is education, of course. That is why all the politicians, when they have excess money, they open up an engineering college or a medical college. Okay, because a father always thrusts on his son what he has not achieved. So if the quality education is guaranteed, then it is like, attracting these bees towards this, fruit. Automatically people will flock. The second one is the medicine. Same in today's context, many of the corporate, they have a hospital also. Escorts have a hospital, TVS have a hospital. So every corporate has got a hospital because medicine will suddenly become important. And the third one is entertainment. When I say entertainment, it can be of many, many things. So whatever I'm saying, if you really look at consumer goods is mostly related to entertainment and pharma is related to medicine. So in pharma also, there is a very good scope. And in fact, you are like Pfizer. In fact, if you go to Vizag, there is a if you go to Vizag, there is a particular park only dedicated. When I say park means the industrial park dedicated only for pharma industries. Hospira, Pfizer, Novartis, so many companies are there. So that is also another good area you can explore. Then textile and clothing is again another big area. Okay, obviously starting from Tirupur, Coimbatore, even in north, many of the areas, textile industry is also good. Glass industry is another thing because in construction today, nobody likes to go for a wall, physical wall. If you go to many of these modern buildings, in balconies, you can see only glass put. Okay, so these glass and also many of the outer facades are also made of glass only. So there are many foreign players like Saint Gobain in India, in Chennai. That is another example of a glass industry. And I have personally done ERP for many of the third-party glass manufacturers. There are hundreds and hundreds of glass manufacturers in and around South India itself. Okay, and similarly, food and beverages industry. Since I worked for ITC, I know very well. And food and beverages, starting from Ashirwad Atta, biscuits, Lotto, Lotte. So many industries are there in food and beverages. And chemical industry, obviously, you can take Sanmar chemicals and so many other chemicals. So what I'm trying to say is the opportunities are many. Mechanical engineers will fit in any of these industries. And as I told, first to find out whether you want to be a technical guy, whether you want to be a people-oriented guy, whether you want to be a system-oriented guy. And similarly, you also decide whether you want to stick to technical or managerial or techno-managerial. Decide your area and then you can go for it. Okay. Sir, go to the next slide, sir. So to conclude, mechanical engineering as a discipline will only get better and better in future. Obviously, one of the example is, the electric cars are coming. So there is an overlapping between mechanical engineering and the other disciplines. Similarly, mechanical engineer will fit in majority of industries. And as a mechanical engineer, you can choose technical, managerial or techno-managerial activities in any organization. Obviously, you should keep upgrading your skills. Okay, people say it is like standing on a treadmill. Even if you have to remain stationary, you have to keep on running. And while you work and earn for yourself, obviously all of you are youngsters and entering into the life threshold of life. So obviously you have to take care of yourself, in future your family. Definitely you do, but at the same time, think of contributing to the society also. All the very best. Thank you. Any questions?
The participant, please post your question in the chat box, or else you can ask.
I hope it was useful, sir.
Yes, sir. Yes, sir. It is useful only.
Very useful, sir.
Sir, one question in the chat box: how mechanical engineering is connected to computer engineering?
That is what I was telling you. Computer engineering is application of mechanical engineering. For example, I will take specific example. Let us say a particular organization is, implementing. Definitely, as a mechanical engineer, you are required to do a business analysis. And if you know this side of the spectrum also, you can, definitely, bridge the gap. Similarly, go take a company where, your computer-aided design is used. Obviously, computer-aided design is only a medium, but medium, you need a mechanical knowledge. Okay. So this is just an example of how mechanical engineering and computer, the computer science or computer engineering is related. Similarly, when you go for any processing equipment, tomorrow they are using IoT, Internet of Things. Obviously, the machine side of it requires mechanical engineering. The IoT side of it requires, either electronics and communication or computer engineering. See, basic engineering cannot be neglected. The computer engineering cannot substitute the knowledge and experience of a mechanical engineer. Certainly not.
Sir, any question? Yes, someone is asking, so comparison between petrol bike and e-bike. So in
Okay,
future.
see, yeah, see, in petrol bike, as you know, we are using a fossil fuel. In electric bike, obviously, we know electricity. And what will happen is in petrol bike, because we are using an engine, and the number of parts are more. Because for you to make an engine, you need a cylinder block, you need, a moving mechanism of a piston ring, blah, blah, blah. Whether it is a single cylinder engine or two-cylinder engine or a four-cylinder engine. Many bikes came now, so obviously the weight of the bike will increase. Whereas in electric bikes, we directly convert the electrical energy into a mechanical energy, so the number of parts are very less. So obviously the weight of the machine or the weight of the vehicle will come down. So when the weight of the vehicle come down, obviously your fuel efficiency will increase, and that is one part. The second part is, of course, for electric bikes to pick up in India, we need to all the infrastructures. In fact, this Ather. Electric bikes in Hosur is my client. We are doing some work for them. But the problem with all these electric bikes is they not only charge you down payment, but they are also giving you only on subscription basis. So even though you get the vehicle, you have to, whether you use the bike or not, you have to pay some amount monthly. So that kind of a marketing model is not nowadays working. So maybe in future, when the demand increases, things will change. So put it in simple terms, electric bikes will have lesser number of components than a petrol bike, a petrol or a diesel bike, petrol bike. So obviously your fuel efficiency will be higher. And of course, the cost will be more because of lower demand. Today, number of demand increases means then to that the cost will come down.
Sir, another question is, so how we can get a final year project from company? So what are the possibilities are there? How we can approach?
From where?
40%
From where? Hello, from where?
How we can get a final year project from company?
Okay, see, what is important here is you should have a see, obviously you should approach companies through your organization only. For example, in one of the companies where I am doing project now, which is Tata Motors, they have requirements for doing structural analysis, because when they change some component, they want to know how the bus behaves. Okay, so if you have the facility of simulation in your laboratory, then you can take up a project. Or let us say there are specific projects, like we are trying to convert an argon and carbon dioxide mix to 100% carbon dioxide. So a project is going on. So somebody can go do the study, record the parameters, do the analysis, and help the project. So like that, the requirements are always there in the industry. But what is important, as an individual, student may not be able to approach the approach the industry. So if through their personal contact, if they know, then they have to bridge the institute and the industry, or the colleges should have a good rapport with many industries, not only inviting them for only campus interview, but also for getting projects like this, so that their name also gets registered. And of course, depending on the performance of the student, the college name also will go up in the radar of the companies. And what you need is only for publishing technical papers, whereas the actual staying and those cost can be absorbed by the companies. They won't mind doing that. But that is how the industry institute interaction should take place. In fact, some of the colleges where I know these kind of things exist is this Suhasi, MEPCO college. They have a beautiful connection in and around Suhasi. Even though it is a small scale industry, still there are some solvable projects. Similarly, some of the colleges in Coimbatore, I know they're also having a good rapport. Like that, institute should develop first a good rapport with the industry, identify the need, and then sponsor the correct students, so that they live up to the expectation of the company. That is how it should go.
Okay, sir. The next question is, can you list out the best courses to study for mechanical engineering for industrial needs?
Okay, I would first say, since I am from, I think the future is there for this industrial automation. I don't know whether you are offering this as a subject. Industrial automation and IoT is the future thing. That is number one. And second one, this lean manufacturing also, I have been talking with you because that is a soft area of mechanical engineering, which is also required, which many of the students even don't even aware of this. When they sit in the interview, at least, this can be even offered as one of the electives. In fact, when I tried, I think NIT Calicut, they have started using this, and some of the other institutes are also, they are doing it. Okay, so that also we can talk about. And of course, the traditional courses are there. If you are interested to go for design into, engine and things like that, then go for, thermal engineering. And if you are interested in fluidity, in aircraft industry and things like that, you have to go for aerodynamics. And if you are interested in static design, suppose I want to join some builders, or I want to join army, there is a particular wing called, engineering division of army, which they only do, build bridges and other things. Definitely static is important. So the vast variety of subjects are important. But to my mind, the biggest demand is for automobile engineering, refrigeration and air conditioning, industrial automation, and of course the traditional areas are whatever I have discussed with you, and of course production engineering.
Okay, sir. This all from our end, sir. Thank you very much, sir. It's a wonderful session. We have learned a lot from. Yes, Arvindan, tell me. You have one doubt. So we have learned a lot from you. So thank you very much, sir. So now I like to Vinod Kumar, sir, to give vote of thanks.
Yes, sir. A very good morning to all. I feel very happy to propose a vote of thanks for these grand occasions. First, I would like to thank our chairman, sir, and co-chairman, sir, for their continuous support in conducting this kind of program. My sincere thanks to our respected chief guest of today's program, Mr. R. Lakshmanan, senior consultant, TAPAMS. He is a busy schedule, sir is giving for that slot. Okay, sir also the covering for the lot, especially for the core area of mechanical engineering. Sir is listed out for that. What are the core companies are available in the South India, and also for industrial automations and the importance of robotics and with artificial intelligence. And finally, that overall view of that mechanical engineer, that is a very informative, sir. I'm really very thankful to you. And next, I would like to thank our respected Dean, sir, Engineering and Technology, for his continuous encouragement. And next, I would like to thank our VP Academics, come HOD of Mechanical Engineering, is guiding and supporting. Finally, I like to thanks to extended my heartful thanks to all the participants and my dear colleagues for extending their support for smooth conduction of this program. Thank you all. Thank you, sir.
Thank you, sir. Thank you so much.
Thank you, sir. Thank you, sir.
Swaminathan, if you can send me the link, that will be
Yes,
great.
sir. Yes, sir. I'll send it, sir.
Thank you.